Antibiotic Resistance. Nevada woman dies from superbug resistant to all available antibiotics in the United States. This was the headline of the front page article posted on LasVegasNow.com on January 14th of this year. The woman who suffered the fatal infection was in her 70s and was treated at a hospital in Reno. The superbug that caused blood toxemia and multiple organ systems failure resisted all 26 U.S. antibiotics. This is the first documented case of an infection that has shown resistance to all known antibiotics in the U.S. A comment from Dr. Ann Shushat, acting director of the Centers for Disease Control and Prevention, stated, "Superbugs with resistant genes represent a catastrophic threat to the public and is one of the scariest threats currently facing the nation." The World Health Organization also commented, saying that these types of superbug infections have disastrous implications and described the situation as the public health ticking time bomb. Microbiologists identified the genus of bacteria that was responsible for the woman's deadly infection, Klebsiella. Klebsiella is a gram-negative encapsulated bacteria that is soil-dwelling and is sometimes seen in the normal flora of the mouth. This bacteria is an opportunistic pathogen and takes advantage of immunocompromised and weakened hosts. 2 years prior to the woman's fatal infection, she was on an extended stay in India. During this time, she had broken her femur, the largest bone in the leg, and had to be hospitalized. It is here that scientists and doctors believe the resistant superbug genes were embedded into the woman. Bacteria are ubiquitous. They are tiny microscopic single-cell organisms that live in every place under all conditions. We have discovered bacteria in the darkest depths of the ocean into molten lava inside volcanoes. In fact, at any given moment, the human body contains 10 times as many bacterial cells as it does human cells. We have lived alongside bacteria since the beginning of time. Many of these bacteria are harmless or even beneficial, aiding in digestion and immunity. It is a rare few genus of bacteria that cause deadly infection and harm to the human body. Prior to the discovery of penicillin, the first antibiotic by Sir Alexander Fleming in 1928, if you had an infection, there was a good chance you could die. Since this time, we have lived in the golden era of these miracle drug antibiotics, and now we are coming to an end of it. We are standing at the threshold of a post-antibiotic era because of a phenomenon known as antibiotic resistance. Antibiotic resistance occurs when an antibiotic has lost its ability to effectively control or kill bacterial growth. Antibiotic resistance is part of evolution and is always occurring. Bacteria gain resistance through two primary ways. Genetic mutation. These are mutations that are rare and spontaneous that alter the genetic makeup of a bacteria. This concept is relatable to Darwin's theory of evolution, in which organisms mutate and thrive to increase their chances of survival. Different genetic mutations can increase resistance in several ways. Some mutations enable the microbe to produce toxic chemicals and enzymes that inactivate antibiotics, while other mutations disable antibiotics' ability to target them as a microbe. The second way is by acquiring resistance from another bacterium. Bacteria can participate in a mating process known as conjugation, in which bacterium can transfer genetic material, including resistant genes, to one another. Viruses are another mechanism for passing resistant traits to bacteria. Resistant genes from a virion can be injected into a bacteria sharing its genetic makeup. Lastly, bacteria have the ability to acquire free DNA and genetic material from their environment. How do antibiotics work? Although there are many types of antibiotics, they all work in one of two ways. Bactericidal agents kill the bacteria. These types of agents interfere with cell wall synthesis and other vital productive components of the microbe. Examples include penicillin and its Pennam derivatives, cephalosporins, monobactams, and vancomycin. Bacteriostatic agents, in contrast, stop bacterial growth and disable the microbe's ability to reproduce and multiply. They limit growth by interfering with bacterial protein production, DNA replication, or other aspects of bacterial cellular metabolism. Examples include tetracyclines, sulfonamides, chloramphenicol, and macrolides. Antibiotics support almost all aspects of our everyday modern lives. If we did not have antibiotics, an estimated 1 in 4 people would die from surgery. People who need life-saving transplants would succumb to fatal infections. Prior to antibiotics, 1 in every 6 women would die from postpartum infections, even in the cleanest of hospitals. Individuals with weakened immune systems, such as AIDS patients, cancer patients, and babies, would be especially susceptible to infection and would have no means of protection against these microorganisms. If we look back through history, most people didn't die from cancer or heart disease or the lifestyle diseases that afflict us in the West today. They did not die of those diseases because they did not live long enough to develop them. They died from injuries and infection. According to research by Dr. Helmuth of Washington University, the life expectancy has more than doubled in the last century. The average life expectancy prior to antibiotics was 30 to 40. Today, that number has doubled, with many people living healthy lives well into their 80s. This would not have been possible without antibiotics. A British police officer, Albert Alexander, was the first person to be treated with penicillin in 1941. He was so ravaged by infection that his scalp oozed pus and doctors had to remove one of his eyes. He was injected with penicillin over the next 4 days and greatly improved within the first 24 hours of treatment. This was a miracle, a medical breakthrough. It was the first ever recorded medication and treatment that improved a person's condition suffering from an infection. Although no one knows the exact manner in which Officer Alexander contracted his infection, it is said that he was doing something very simple. He was walking in his rose garden and scratched his face on a thorn. If we enter a post-antibiotic era, is it possible that we could revert back to a time when things like that were possible? A time in knowing that any possible injury could be fatal? How would that affect your everyday life? Would you let your kids play outside, participate in sports, ride a motorcycle, or take part in any of the daily activities we have grown accustomed to? If only we could have seen this coming. If only we could have prevented what seems to be like imminent disaster. Well, this was preventable, and it was even predicted by Sir Alexander Fleming himself. A quote from him stated, "The thoughtless person playing with penicillin treatment is morally responsible for the death of the man who succumbs to infection with the penicillin-resistant organism." In 1945, less than 5 years after the introduction of penicillin, scientists discovered penicillin-resistant bacteria. The British Project estimates that right now there are nearly 700,000 deaths a year due to infection around the world. And if we don't get this situation under control by 2050, that number will increase to 10 million deaths annually. The question is, how did we get to a point where this is possible? The difficult answer is, we did this to ourselves. Resistance is an inevitable biological process, but we as a society are responsible for rapidly accelerating the process. Penicillin was sold over the counter until the 1950s, and in much of the developing world, antibiotics still are. Agricultural aspects plays an even larger role in the misuse of antibiotics. Most meat animals get antibiotics every day of their lives, not to cure illness, but used prophylactically to protect them against the factory farm conditions they live in. In 2015, the CDC estimated that nearly 80% of antibiotics sold in the United States went to farm animals, creating resistant strands of bacteria that spread off the farm, in the water, in the wind, and in the food the animals become. Can we avert the post-antibiotic world? Companies are working on novel antibiotics, things that superbugs have never seen before. We need incentives like research grants, discovery patents, and prizes, things to lure large medical companies into researching and making antibiotics once again. Bacteria can birth a new generation in as quickly as 10 minutes. It takes pharmaceutical companies years to derive a new drug. Every time we use an antibiotic, we give bacteria billions of chances to find ways to beat it. There has never been a drug that bacteria could not defeat. We are fighting a losing battle, but we can change the outcome. We can build systems to automatically and specifically identify microorganisms to be sure we are giving the correct and most effective antibiotic treatment. We could establish gatekeeping systems in pharmacies so that every prescription gets a second look. And we could require agriculture to give up antibiotic use. Penicillin began the era of antibiotics in 1941, and in just 75 years, we have arrived at the edge of disaster, unless we make a change today.